So welcome back to my video. In the previous video, I have already shown you how to construct this basic circuit for operating a DC motor by using the transistor 2N222 and also the resistor, capacitor, and the diode. Yeah, and I have already explained why this construction is like that, the basic principle of this circuit here, and also I have given you a chance to construct this whole circuit by using either this Proteus, in this Proteus, or also in this hardware. So anywhere you want to use, hopefully you already have completed this circuit. Because in this video now I will directly go to the coding. So if you don't construct this circuit yet, you can pause this video and construct this circuit. But if you don't watch the previous video yet, you don't know why this circuit is constructed like this, please watch the previous video before you proceed with this video, because in this video I will directly go to the coding. So if you have this circuit, if you already understand why this circuit is constructed like this, so let's now go directly to the coding. So if you have already completed the circuit, as usual, let's go directly to the coding. But actually the coding, there is no new information on the coding. Basically in this chapter, the most important thing is this, the main information in this video is the circuit that I want to show. How to construct the circuit for the motor. In terms of coding, basically you still use the same coding before, which is the digital write and analog write. So if you want to make the motor, for example, if you have the motor, if you want to turn on the motor, so just set it as high, and if you want to turn off the motor, then just make it low. That's it. And if you want to change, let's say if you want to change the speed, so as usual we use the PWM output from the port 3 just now, which is we use the analog write again with the motor ports, and then the value of the PWM from 0 to 255, any value between 0 to 255. So basically this is if you want to change the speed of the motor. If you just want to turn on and off, like a fan for example, if you just want to turn on and off, and therefore you just directly use the digital write with high and low. If you want to change the speed, so this is the coding. So basically there is no new information on the coding, and therefore I don't want to waste your time by writing up the coding from the beginning. So I will just only edit the coding from the PWM video previously. So if you don't watch the PWM video, or if you don't have this coding previously, so you can go and watch the PWM video first, and before proceeding with this video here or this coding here. But if you already have this coding, so you can just reopen this coding again, open it up, and then save as a different name, and then we can just directly edit from there as usual. Because I'm not that hardworking, I'm just a lazy person. So if you want to follow this lazy person, so this is how you do it. So just open up the coding from the PWM if you still have it. But if you don't have it, so you can pause this part of the video first, and then try to follow or try to write this code again. I don't want. If you don't have any idea on the PWM, as usual, you can go ahead and watch the previous video on the PWM, because we will use that information here. So what happens here now, instead of we want to control the LED, we will control the motor, which is at the pin, basically the motor from the pin 3. So from the pin 3, so if you follow the same coding or the same pins assignment in the Tinkercad or in the Proteus. So basically the motor is at the pin D3, and therefore we use here as 3. So basically this is motor for pin 3. So that's it. And because of that, we need to define motor as output. And then we just change here into motor. This is also into motor. Now you see why I just use this coding, because I can just copy and paste everything. And if we want to check slowly the increment of the speed, basically what happens in this coding here, it start with 0, meaning that it is turned off, and then it increase one by one slowly. So if you want to check slowly the increment slowly, so maybe I can increase the delay a little bit, so that it the speed is increased slowly. And if we want to check the movement at the maximum speed before it reduce the speed again, maybe again here I can also put one more delay here. If let's say if you want to make it turn for about 3 seconds, so just include here 3000. So and then it will, after that it will goes out from this for loop here. It will start to drop, the speed will start to drop. The I value here will start to drop from 255, drop one by one until it reaches 0. And for every 20 milliseconds, and after that, after it stop, it will wait for 3 seconds before it turn on again. So this is basically how the coding is, the same coding as the in the PWM video, just I change the LED into motor. So if you want to take time, for example, if you don't have this code before, so you can just take your time, you can just rewrite this coding, pause this video and rewrite this coding. But if you have saved this coding previously, and then you can just directly run this coding here and just edit just like I've shown you in this part here. So this is how the codings are. There is no new information, there is no new coding, there is no new syntax. It's just the same analog write and digital write, and therefore we can try to run this coding here into the Arduino if you have hardware. If you don't have hardware, as usual, if you have the Proteus, so you can just export compile binary or copy and paste the hex file. If you have hardware, so again make sure you can connect your hardware into the computer first. So after you have connect your hardware to the computer, so as usual, make sure you check first you use the correct Arduino and the correct compose, and just click upload. So let's wait until it completely upload. So done compiling. Now it is already done compiling, done uploading, which means that we can try to see it in our hardware. So this is our hardware. So now let's connect this this battery ports here with the 9-volt battery here. So let's use this battery, make sure you connect it correctly. So now after we have connect the battery, so as you can see here, now it move at the maximum speed. So as you can see, it move at the maximum speed, and then it stop, and then it start to move at the increment speed until it reach the maximum speed, and then it start to slow down until it stop. So now let's try to run this again with a slow movement. So if you can see, with the slow movement, the rotation is increasing slowly, and then it will reach a maximum speed, and then it will slow down again until it reach the stop, the dead stop. So this is, if we look at in the slow motion, so that's it. That's how you do it for the hardware. So as usual, for the Pro Tools, just export compile binary, then it will export into the hex file. So again, open your Pro Tools and make sure you find the correct hex file. So again, at which folder that or directory that you save your hex file, open. So again, then you can just click play, and when you start play, as you can see, it shows the speed there, and the speed is also changing until it reach the maximum speed, and then it will drop again. It will drop until it stop for about 3 seconds, and after that it will start to turn again. So this is for the Pro Tools, and as usual for the for this Tinkercad here, the same thing and no different. So you can read the RPM value here to see the speed is changing, because in the Pro Tools and in the Tinkercad you might not really see the movement because it only give you the gear image here without anything, and because you can't see the movement, and therefore you can just rely on this value of the RPM here. It reach the maximum RPM, and then it will start to drop slowly until it reach 0. That's it. So that's how you do it. I think it is very easy, because the coding is there is no new coding that are shown here. It's just the same coding in the PWM, in how we brighten up the LED and then fading out the LED slowly. But now we just increase the speed of the motor and we reduce the speed of the motor slowly. And since this part here is too easy, especially if you already do the PWM and also the other tutorials before, so basically I can directly give you one challenge here. The challenge number 1 as your exercise, which we have this circuit here. You can construct this circuit. This is the same circuit, just we add this potentiometer here at the port A5. So that's it. This is just exercise, so you don't need to worry about marks or anything. So no marks for this, or you don't need to submit, because this is only for exercise for you. If you still don't have any idea to control how to control the motor speed by using sensor, for example, if you have distance sensor, if the distance is getting closer and closer and closer, then the speed will reduce until it stop. So this is how we do it. Basically, this potentiometer is just act like a sensor here, which this is the analog sensor, and if the resistance is reducing, so basically this motor here will also reduce. So here is the simulation for it. As if you don't have any idea what I'm going to say here. So if the potentiometer is at 100%, as you can see, this motor here is moving at the maximum speed, and then when I reduce it to 73%, so the speed is reducing 46%, and then to 30%, and when I reduce it further to 14% and until the 0%, so it will fully stop. So this is if you have if you don't have hardware again, so you can use this Pro Tools here for simulating this challenge here. If you have hardware, so as usual, just connect according to this circuit if you want, or if you just also can follow the Pro Tools and then connect the hardware on your breadboard like this, and also then you can try to rerun this circuit on the hardware and just adjust the potentiometer here. As you can see, the value is reducing, the RPM value is reducing until it dead stop. Yeah, so basically this is how you control the movement of the robot tire, for example, from the maximum speed. And then when, if you have, again, if for example, if you have distance sensor, so if the distance is getting closer to the obstacle, for example, the motor will reduce the speed slowly until it dead stop. So this is how you control the motor by using any sensor. So I just ask you to try to do this by using the potentiometer first, which you can use the coding from the previous video on the temperature sensor, or on to control the LED brightness by using the potentiometer. So because it is the same coding, just like previously, I just copy and paste and then just change into motor. That's it. That's why I don't show the answer here, but if you have any problem, as usual, you can directly ask me. I will more than happy to help you. Don't be shy to ask me, although it is already covered. But if you cannot have don't have any idea on how to apply on the motor control, especially if the coding is already correct but somehow your motor is not functioning, so you can always ask me. I will be there for you. I will help you, hopefully, if I can help. And that's it for this time around. So please try to do this one challenge here, this challenge one here, to control the speed using potentiometer. And that's it for this time around. Hope you enjoy this video, and as usual, if you like this video, please click the like button down below, and don't forget to subscribe. And you can also ask other people to subscribe as well if you think they need this information here, they need this video here to do their project, for example. And yeah, that's it from me for this time around. Stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.